right, example 3 is another retirement scenario. So here we go. At the time they retire, a couple has $200,000 in an account that pays 8.4% compounded monthly. If the couple decides to withdraw equal monthly payments for 10 years, at the end of which time the account will have a zero balance, how much should the couple withdraw each month? Okay, take a moment, read through the problem again and again until you have a good understanding of what's going on, okay, and then resume the video. Okay, so what's going on here? Okay, the couple has already saved for retirement, okay? So if I go back into this color coding system that we had in the last problem, okay, yellow is where you're saving for retirement, and then the second part of retirement, you're actually living off of that money, and that's what I had in teal, okay? So what's going on here, okay, they've done the saving already, okay? So at the time that they retire, they have $200,000 saved up, okay? And so now they're going to be living off of this money, okay? So what they're going to do, they're going to withdraw equal monthly payments for 10 years, okay, bringing the balance down to zero, okay? So we're trying to figure out how much they can withdraw each month to live off of, okay? All right, so this problem, okay, again, can't emphasize enough, it is not involving saving for retirement. They've already done that. They've got $200,000 saved up, okay? So if they're living off of that money, okay, remember, $200,000 is how much they're, going into retirement. They have a balance of $200,000, and then they're going to make monthly withdrawals out of this account, okay? The amount that still lives in the account is going to continue to earn interest, okay? So what we're trying to figure out, how much should the couple withdraw each month, okay? So what's going on here is an annuity is being paid out, okay? This couple is going to be receiving equal monthly payments for a 10-year period, okay? So the annuity is being paid out, okay? So since the annuity is being paid out, we're going to use the present value of the annuity formula. Okay, so present value of an annuity formula is this. Okay, I'm going to go ahead and write that down because that's going to be our formula here. Okay. All right, so we need to figure out what we're looking for and what we know. Okay. All right, so let's do our obvious variables first. Okay, we know the interest rate of the account is going to be 8.4%, so 0.084 if you convert that to a decimal. Okay. The interest, okay, because remember, their account, whatever money is still in the account is still going to earn interest. Okay, so that's why there's an interest rate here. The interest is going to be compounded monthly. So that will also coincide with how often the payments are. They are going to be receiving monthly payments out of this retirement account. So M is 12 here, okay. Time, okay. They are going to withdraw money for a 10-year period. It tells you that right here, okay. So T is 10, okay. That leaves us with PV and P, okay. We've got to figure out which one we're looking for and which one we know, okay. So again, going back to your formula sheet, understanding the meaning of these two variables, PV is the one lump sum that needs to be invested in order to pay out the annuity, and then P is the amount of each regular payment to the recipient, okay? So which one of those are we looking for, okay? Well, we're looking for P, okay? Read this last statement here. How much should the couple withdraw each month, okay? What is going to be the monthly payment to this couple? Okay, so we're looking for P. Okay, so that means we know PV. Okay, PV is the one lump sum that is invested to pay out this annuity, to pay out this couple monthly for 10 years. Okay, well, present value. Okay, at the time of retirement, right now, how much does the couple have? Okay, the present value of their retirement account, how much they have right now going into retirement, is $200,000, okay? That's the amount that they're investing, okay, to pay themselves monthly for 10 years, okay? So the present value of the account is $200,000, okay? All right, so let's plop this into the formula in the calculator and we can figure out how much the couple can get paid every month for 10 years. Okay. All right, so here we go. Let's plug this into the formula. So we're going to get 200,000 is equal to the p-value times 1 minus 1 plus 0.084 divided by 12 raised to the negative 12 times 10 over R over M. Okay. Whoops, I forgot my 8 there. Okay. All right, so now we need to go to the calculator, put this in. Okay. So complicated formula. Okay, we're going to start inside the brackets and we're going to input the numerator. Okay. Once we have the numerator, we will come back and divide by the entire denominator. Okay, that will give us the quantity that is in brackets. Okay, and then once we have the quantity in brackets, we will go ahead and go from there. Okay, because that will be the value, that will be the number that p is being multiplied by, and we'll go from there. Okay. So let's go to our calculator and punch this in. Okay. All right, so starting in the numerator, I'm going to have 1 minus, open parentheses, 1 plus 0.084 divided by 12. Okay, close parentheses. Okay, raise it to a power. My exponent is going to be negative 12 times 10, close parentheses. Okay, get out of the exponent. Okay, here is the numerator. Okay, I've got to carry all those digits. Okay, so now we need to divide by the denominator, which is R over M. So hit your division key. Okay, open parentheses. You've got to put this quantity in parentheses or it's not going to come out correctly. Okay, so we're going to divide by 0.084 divided by 12, close parentheses. Okay, this is the quantity that is in brackets. Okay, so let's go ahead and jot this down because this is the number that P is being multiplied by, and you're going to have to carry all these digits. Okay, so on the right side of my equation, I've got P times, we just calculated this number in brackets, it's 81.00346,993. Okay, on the left side of the equation, we still have 200,000. Okay, so we've got to solve for P, the amount of each payment to the couple. Okay, so P is being multiplied by this 81.00 blah, blah, blah number. Okay, so we're going to have to undo that by dividing both sides by this number. Okay, so let's just jot this down. Okay, whatever you do to one side, you have to do to the other. All right, so on your right side, okay, this decimal will cancel with this one. Okay, it's going to leave us with P. Okay, so we just need to go to our calculator and do 200,000 divided by this 81 point something number. Okay, so let's go back and do that. So I'm going to hit 200,000. Okay, divided by, I'm just going to call up this previous answer. Okay, or you can just type in all the digits again. Okay, so I'm going to do second the negative sign here to get the answer function to pull up. Okay, and here we go. Okay, so this is going to be the amount of money that the couple can receive each month. We are going to have to round it to the nearest cent because this is dollars and cents. Okay, so let's jot this down and then round. Okay, so this is going to be out of the calculator. We have 2,469.030033. Okay, round it to the nearest cent. Okay, so we've got 3 cents. A 0 comes after. So we are going to keep it at 3 cents. Okay, so every month for 10 years, the couple can receive $2,469.03. Okay, so that's the answer to the first part. Okay, again, realize that to solve this problem, okay, we did not take the amount at retirement and divide by 12 payments a year times 10 years. Okay, if we had done that, okay, and taken 200,000 and divided by 120, the number of payments, okay, that would give the couple $1,666.67 per month, okay, which is a lot less. Whoops, that's a lot less, okay. But remember, that is completely incorrect. That is not the way to go, okay, because if you do it that way, okay, it doesn't take into account that that $200,000, whatever's in the account, is still earning interest over the 10-year period, okay? So that is not the way to do this problem, okay? The way we did it and set it up and plugged into the present value of an annuity formula to come up with a monthly amount of $2,469.03. That is the correct way to do this problem, okay? All right, let's move on to part B. In part B, if the couple decides to withdraw $3,000 a month until the balance in the account is zero, how many withdrawals can the couple make? Okay, so this is a little bit different than part A. Okay, we're still involving the same couple, same setup pretty much. Okay, so let's think about what we did in part A. Okay, just to clarify. Okay, so in part A, remember the couple saved $200,000 for retirement. Okay, and then they started withdrawing money from this nest egg. Okay, and they withdrew money for 10 years. Okay. And we calculated that they could withdraw $2,469.03 per month. Okay, so in doing that, they did this for 10 years. Okay, monthly payments. Okay, so they got, how many withdrawals did they have? Okay, well, one a month. Okay, so that's 12 months in a year for 10 years. Okay, so there were 120 withdrawals. Okay, so now what's going on, okay, we're still assuming the same nest egg. Okay, so this couple enters into retirement with the $200,000. That's their nest egg. Okay, and now we're going to say, okay, let's switch gears. Okay, instead of withdrawing money for 10 years, okay, and being able to withdraw $2,469.03 per month for 10 years, okay, let's decide, let's live a little bit more lavishly, okay, and let's take out $3,000 a month until the balance is zero, okay. How long can we do this for? Okay, how many withdrawals can we make? Okay, so it's a little bit of a different retirement setup or scenario for this couple, okay. So basically what's going on now, this couple is instead deciding, okay, I want to be able to withdraw this much money per month. Okay, how long can I do this for? Okay, again, notice the difference between this and part A. Okay, because part A, you had your time set. I want to be able to survive for 10 years. How much money do I have to live on per month? Okay, now it's like, I want to be able to live on this much money, on $3,000 a month, but how long is the money going to last now? Okay, so like I said, a little bit of a different setup under the same conditions. Okay, all right, so one thing we know about this going into this problem, okay, the couple in part A, they were able to make 120 withdrawals if they took out $2,469.03 a month. Okay, but now in part B, they're taking out more money per month. Okay, they're bumping it up to $3,000 a month. Okay, so since they're taking out more money each month, the money won't last as long. Okay, so we expect our answer to be less than 10 years. Okay, a 10-year time period for which they could withdraw the money. Okay, so let's take a look at it and try to solve this problem. Okay, what are we looking for? Well, we're trying to figure out how many withdrawals the couple can make. Okay, how long is this money gonna last? Okay, so essentially we're solving for time here. Okay, so again, the annuity is being paid out. They are going to receive regular paychecks of $3,000 a month. Okay, so it's the same kind of thing going on here in that an annuity is being paid out. Okay, so once again, we are going to use the present value of an annuity formula. Okay, so I'm going to go ahead and write that down. Okay, we're looking for this formula. All right, so again, let's figure out what we know, what we're looking for. Okay, we are assuming the same interest rate. Okay, the interest rate was 8.4%. Okay, so let's write that down, convert that to a decimal. Okay, they are still making monthly withdrawals. Okay, which corresponds to how often the interest is being compounded. So illness is going to remain 12 for part B, okay? And time is what we're looking for now, okay? Because we're trying to figure out, if they were drawing $3,000 a month, how long can they keep this up for until the balance is 0, okay? All right, again, we should know PV and P since we're looking for time here, okay? So going back, or well, let's go with the easier variable here, okay? So remember, P is the amount of each paycheck to the recipient, okay? The couple wants to receive monthly payments of $3,000, okay? That's going to be each payment to the couple, okay? PV is the amount of money, that one lump sum that is going to pay out this annuity, okay? So remember, you're going back kind of to the beginning of the problem, okay? At the time of retirement, the couple has $200,000 in their nest egg, okay? So that one lump sum here is still going to be $200,000, okay? That's how much they had at retirement, and that $200,000 is going to fund their retirement years, okay? All right, so we are going to plug all of this in. Okay, let's set it up. So all right, so let's go ahead and plug all of this into our formula. Okay, so we're going to have 200,000 is equal to 3,000 times 1 minus 1 plus 0.084 divided by 12 raised to the negative 12t power all over R over M. Okay, we are solving for time here, okay, because if you're trying to figure out how many withdrawals the couple can make, that is tied to time. How long is this money going to last, okay? All right, so we've got to solve this guy for time, and time is in the exponent, okay? So essentially, we have to follow our steps for solving an exponential equation, okay? First step is going to be, we need to isolate the quantity that is being raised to the exponent, okay? This stuff on the right side, very, very complicated, okay? But what is being raised to the negative 12t power? Well, this thing in parentheses, okay? So this that I'm circling in red, that is what we are going to have to isolate, okay? Notice the negative is not being, this negative right here is not being raised to the power. It is outside of the parentheses, okay? So we need to isolate the quantity, parentheses 1 plus 0.084 divided by 12 to the negative 12t power, okay? Once that is all isolated, we will apply a logarithm, okay? So let's concentrate on isolating this thing that I have circled in red, okay? We are going to work from the outside in, okay? So all the stuff that's in brackets, okay, that's attached to, one another, okay? What's not included in the brackets is the 3,000, okay? So we're going to start there, okay? This stuff in brackets is multiplied by 3,000, so we're going to do the opposite. We're going to start by dividing both sides by 3,000, okay? On the right, 3,000 divided by 3,000, that will cancel, okay? I am going to go to my calculator and punch in 200,000 divided by 3,000, okay? So let's do that. Okay, so we're going to get, let's see, 200,000 divided by 3,000, okay? We would have to carry all these digits, okay? Notice the decimal part, the 0.6 repeats, okay? So that means you can convert this to a fraction. So I'm going to go ahead and hit math, option 1 to convert to a fraction, hit enter, okay? So this is going to give me the reduced fraction, so it's a little bit easier to work with than carrying all the digits, okay? So this is going to give us 200 divided by 3 on the left side, okay? On the right, what's left is the quantity in brackets, okay? So I'm going to go ahead and drop the brackets, but what's inside the brackets, that's what's left, okay? All right, so that's our first step, okay? And now, again, like I said, this is what we're after isolating, okay? So in the numerator, the stuff in the numerator, the 1 minus 1 plus 0.084 divided by 12 raised to the negative 12t power, that stuff is all married to each other, okay? So the numerator is separated from the denominator, okay? So we're going to next get rid of the denominator, okay? So since the numerator is divided by the denominator, the opposite of that is multiplying by the denominator, okay? So I am going to go on the right, okay? On the right, we're dividing by r over m. The opposite is multiplying by r over m, okay? Whatever you do to one side, you have to do to the other, okay? So now we're going to multiply by r over m, okay? And let me draw myself a little line here so that I can, separate my previous work from my current work. Okay, let's just put a little partition here, okay, so we don't mix up our stuff, okay? All right, so we are basically multiplying both sides by r over m, okay? On the right side, what's going to happen, okay, is you're going to have r over m in the top, and that's going to cancel with r over m in the bottom, okay? And so you would be left with basically the numerator, okay? So you're going to be left with 1 minus 1 plus 0.084 divided by 12 raised to the negative 12t power, okay? I'm going to go to my calculator and multiply 200 over 3 by r over m, okay? So I'm going to multiply 200 over 3 by r over m, okay? This will also convert to a fraction because the 6 repeats, okay? So I'm going to hit, that's just easier to work with in my opinion, than the fraction's easier to work with than the decimal, okay? So I'm going to hit math, option 1 to convert to a fraction, okay? This is going to be 7/15, okay? So let's go ahead and hit that. All right, and that's where we are, okay? Oops. So let's keep going, okay? Again, what do you want to isolate? This quantity, okay? So we've got to deal with this 1, okay? When you look at the 1, it's 1 minus the quantity in parentheses, okay? The 1 is positive. The 1 is positive, okay? So essentially what you have in this statement is, since it's a positive 1, you're really adding 1, okay? So the opposite of that is subtracting 1, okay? Since you subtract 1 on the right, you're going to have to subtract 1 on the left, okay? So let's go to our calculator, okay? Let's do 7/15 minus 1, okay? So let's see, we're going to have 7/15 minus 1, okay? We'll go ahead and convert this to a fraction, okay? That's going to give us negative 8/15, okay? So we're going to get negative 8/15 is equal to, okay, on the right, what canceled? 1 and negative 1, okay? This negative sign right here is still there, okay? So write it, and then you've got the quantity in parentheses raised to the negative 12t power, okay? All right, so we're almost there, okay? If you look at the red box, what do I have isolated? Well, the stuff in parentheses and the exponent. The negative out front, this negative, which is this negative, that is not raised to the exponent, okay? It is outside the parentheses, okay? So we've got to get rid of that, okay? So if you notice, okay, on both sides of the equation, okay, both sides of the equation are negative, okay? So we're going to go ahead and divide or multiply both sides by -1, and that's going to turn both sides positive, okay? So I'm going to jump to the next page because I've ran out of room here, okay? I'm going to write what I have. Okay, so both sides are going to become positive, okay? So we are going to have 8/15 is equal to 1 plus 0.084 divided by 12 to the negative 12t, okay? Now, that quantity I had boxed in red, it is now isolated on the right side, okay? So now we continue, okay? Once the quantity that's raised to the power is isolated, okay, now you can apply the natural log, okay? I'm going to take the natural log of the left side, okay? Whatever you do to one side, you have to do to the other, okay? So I'm going to take the natural log of the right side, okay? Remember, we use logarithms to get the, bring the power out of the exponent, okay? All right, so now we can apply the property of logarithms. On the right, I've got the logarithm of something to a power. So this power is going to come down in front in the next step. So we're going to get the natural log of 8/15 is equal to negative 12t times the natural log of 1 plus 0.084 divided by 12. Okay. All right. Okay. The negative 12t, that exponent, it has come out of the power. Okay. So this is going to make our life so much easier if we're solving for time. Okay. All right. Remember, when you're solving for time, we're not going to solve for just t. We're going to solve for m times t. Okay. So what we're going to do next is we're going to try to isolate the exponent, the negative 12t that came down. Okay. It is multiplied by this logarithm, natural log of 1 plus 0.084 divided by 12. Okay. This is just a number if you punch it into your calculator. Okay. Since you're multiplying by it, the opposite is to divide by it. Okay. So we're going to divide both sides by this logarithm. Okay. And let's see what we get. Okay, so if we do that, okay, this will cancel with this. Okay, so on the right side, you are going to be left with negative 12t. Okay, and I'll just rewrite this for your notes. Okay, all you have to do is go to your calculator and divide these two logarithms. Okay, and then we will almost be done. Okay, so let's jump to the calculator here and put these in. So here we go. Okay, so we've got natural log of this entire fraction, okay, so put the fraction, then close parentheses, divided by natural log of 1 plus 0.084 divided by 12. Okay, here we go. Okay, I'm going to go ahead and jot this decimal down in our notes, and then we'll talk about how to interpret this. Okay, all right, so we get that. All right, so on the right, we've got negative 12t. On the left, we got negative 90.11517598. Okay, so that brings us to this statement. Okay, notice this is really important here. Both sides are negative. Okay, we're solving for time. Negative time does not make sense. Okay, so since both sides are negative, we're going to make both sides positive. Okay, and then we'll have positive time. That makes sense. Okay, all right, so this is where we stop and interpret. Okay, the 12 in front of the t means that we are talking about months. Okay, so here's another really, really, really important thing with this problem. Okay, in the past, we have been solving for time, and we always rounded up time. Like, for example, in this case, we should be rounding to 91. Okay, you only round up time when you are saving money. Okay, we're doing the opposite here. We're withdrawing money, not saving money. Okay, so what happens here, okay, since 90 is the whole number here, okay, this tells us the couple can make 90 full withdrawals and then some. So they don't have enough, there's not enough time here to make a 91st withdrawal. Okay, so you round down when solving for time and withdrawing money. Okay, conversely, you round up when solving for time and saving money. Okay, so that's a little bit of a difference when you're solving for time. It just matters, you know, you're going to round based on whether you're withdrawing money from your account or if you're saving money. Okay, all right, so again, when you look at this decimal, the couple can make 90 full withdrawals. Okay, so that's the answer. Remember, this was months. Okay, they could withdraw money for 90 months. Okay, they're doing monthly withdrawals. Okay, so they can make 90 withdrawals here. Okay, so that is the answer. Okay, so I'm gonna go ahead and write that down. Okay, so I will write here. Okay, the couple can withdraw $3,000 a month for 90 months. Okay. 90 months. How many years is that? Okay. Just to make sure this is a sensible answer, you can leave your answer as 90 months. Okay. Because that is the answer. Okay. You're doing monthly withdrawals. Okay. So 90 months would be 90 withdrawals. Okay. So let's just compare this to part A. Okay. So if you have 90 months, let's see how many years that is. Okay. So it's 7.5 years. Okay. That is a sensible answer that we got. Okay. Why? Okay. So I'll even write that here, 7.5 years. Okay. Why? Okay. In part A, what happened in part A? In part A, we found out that they could, let's see here, wrong page. Whoops, hold on. In part A, we learned that they could withdraw $2,469.03 per month. Okay. And they could do that for 10 years. Okay. But in part B, they bumped up the amount of money that they were withdrawing to $3,000 a month. Okay. So their money's not going to last as long. So it's got to last less than 10 years. Okay. So certainly 7.5 years, okay, or 90 months or 90 withdrawals, okay, that is a sensible amount of time. All right. We'll do one more example with present value of an annuity, and then we'll move on to amortization.